First question. With the context above, I'll have to scroll back up. What values will be printed to the console by running the following code? Oh, I don't really need the context above now. So I can just look at this. I can understand how functions work. Let me give you some ideas. When I run this function right here, nothing's going to happen. There will be an object created called fun_a. That's the end. When I run this, it will run the function with a certain input. It will then produce an output data. And in that process, it will also print off the value of x because inside the function, there is a function saying to print off the value of x. Since the value of x in this situation would be 1, it will print off the number 1. It will not print off 2. 2 was stored inside of out. That's the end. It was just stored. It was not printed. Next one, same exact thing. We run the function, nothing gets printed. We use the function. That triggers x to be printed, so it does print off 1. But I then say just the name of the object. And outside of the context of a function or a for loop for whatever reason, outside those contexts, just saying the name of an object tends to print it off. And that is absolutely what's going to happen here. If I just say out, it will print off its value, and its value was 2 because it was x plus 1. Here, the exact same thing is going to happen, except the difference being here, I assigned the output to object out, causing it to not print off 2 when it first ran line 50, only once it ran line 51. In this situation, because I haven't assigned the output of the returned data, R just prints it. And so it ends up causing 2 printing events to occur inside the function, printing off the value of x. Then once the function has exited, returning the data to the user, printing off the value 2. Hi, sorry, my parents called, so I had to pause it, and we're all good, but it was important. Anyways, I'm going to continue now. If there was a weird interruption, I'm sorry. I don't remember what I was saying. It was an important call. Anyways, let's do. Next thing, what value will be printed? Am I recording? Yes, I am recording. Good. What value will be printed after running the code? So you've run this code down here, and then you're running fun_b y. All right, let's go through this. So we have, it's hard to point. My finger disappears. I won't point. I'll point with the cursor. So we have a function with 2 arguments. Y's got a default value. X does not. Change a whole lot of things. Then we do x plus y squared, making z, and then returning that output z. I'm then outside the function assigning the value 10 to y. Cool. I'm then using that value here, which means that I'm actually telling fun_b the value 10, and it's having to figure out what to do with the value 10. Well, because I've given it a single unnamed argument, that will become the first argument. That's just based on order. This then works, not producing an error because x has a value, it's 10. And then y, the internal version of y, is the value 4. And so then it becomes 10 plus 16, so 26. Did not work. Why didn't that work? 26. My keyboard must be out of power. There. All right, next up. Pretty much the exact same process. This does not matter at all. We are sending fun_b the value 5. That becomes the value for x for the exact same reasons, because this was an unnamed value or an unnamed argument that therefore it gets assigned based on order. So this becomes 5. That's now 4. So this is now 5 plus 16, so 21. Next, we are running fun_b where y equals 2. So that's going to overwrite the default value. And then we're saying the number 10, because this doesn't say y equals y. This is just object y. And on the outside of the function, object y is the value 10. Since that's unnamed, it's going to go to the first unnamed argument in the function, which is x. So x is 10 and y is currently 2. So that becomes 10 plus 14. Just for the record, I don't like actively try to trick you on the exam. Like, this is an example of like the kind of understanding I need you to have, but the test question is more straightforward. As long as you understand these rules and like you've kind of puzzled through this and you're able to puzzle through it the same way I just puzzled through it, then you're going to do great. That just make sure you do understand those rules, you know the order in which they get applied, and you'll be good. In the code below, I do more than just simulate normally distributed read depths from our norm. I simulate 80,000 loci and then simulate reading them 1 million times. I then apply a minimum depth filter. This is a common quality control step in sequencing technology. And finally, I visualize the simulated read depths. So that is what's happening here. I am sampling from 80,000 loci. So this is as if I'm pulling from a hat. This actually emulates my pecan research a little bit because I used to do sequencing near restriction enzyme sites, and there was about 80,000 restriction enzyme sites. It was actually a little bit more, but I am replacing them. So I'm pulling them from a hat and then putting them back, and then pulling from a hat, putting it back, and so forth. And then afterwards, I'm seeing, well, how many times did I draw each location? And so some locations got drawn fairly few times, but we restricted those values that they did not print. Some values got pulled a certain number of times that was more than the rest. This would be like our mode. Here is the mean being visualized. So we can see that that's shifted over a little bit because this data has been removed. Is that actually the question? How would the mean used to generate the normal data compare to the mean of the filtered data? Well, the mean, if I was simulating this with a normal distribution, which again, this actually isn't. This is, it's like the cumulative binomial distribution resulting from a sampling of a Poisson distribution. Ugh. I don't understand. I mean, I barely understand each of those individual concepts. I understand how the data is generated pretty well, but once you start throwing all that statistics vocabulary at me, even I start to get lost, and I have quite a bit of experience with this. But anyways, it looks like a normal distribution. It can even be kind of visually similar to a normal distribution. It's not a normal distribution. It uses a non-continuous values. It doesn't technically follow, at least not perfectly, the pattern of a normal distribution. Like if I made a QQ plot of it, it would look decent in a QQ plot. But obviously down here, it would be very bad. And then usually the tails are a little bit strange looking. But anyways, here I can see that my mean of the overall data is skewed to the right because I've removed some of the smaller values from what should have been a symmetrical distribution. So in other words, in summary, the mean used in the R norm to simulate this data would be less than the mean of the filtered data, which is what we're seeing here. If I had simulated this distribution, my mean would have been here. And the actual like observed mean would be out here due to the removal of those smaller simulated values. And that's it. Hopefully you learned from that. Let me know if you have any questions, but not in the comments. I don't read those. Don't do it. Send them in your messages. Goodbye.